Hello, I'm Valeria Garcia and I'm going to present my regression analysis final project about heart diseases. I will start with an introduction where I represent my research question, hypothesis, and describe my data. I also include an exploratory data analysis. Following my final regression model, the model output where I choose the type of model and interpretations from the coefficients. I also include a discussion of the model assumptions and model fit analysis. In the discussion on limitations, I include conclusions drawn from the model. In the conclusion section, I summarize my project, and finally, I include my reference. Cardiovascular diseases are the number one cause of death globally, taking an estimated 17.9 million lives each year, which accounts for 31% of all the deaths worldwide. Heart failure is a common event caused by cardiovascular diseases. I wish to estimate the likelihood of a possible heart disease event assessed by a model in order to evaluate the severity of patients with cardiovascular disease. Hence, my research question is, what are the main health issues producing heart failures and at what age are these issues more lethal? A natural hypothesis to make is that the age does contribute to aggravate the ailment of a person already has. Therefore, the obvious response variable for this model is going to be heart disease, a quantitative variable which takes only two values, 0 and 1. This variable represents whether a person has a heart disease or not. The dataset I used was retrieved from Kaggle, and it contains all the following variables: age of the patient in years, sex of the patient, chest pain type, resting blood pressure, serum cholesterol, fasting blood sugar, resting electrocardiogram results, maximum heart rate achieved, exercise angina, all peak, the slope of the peak exercise, and output class. However, for the model, I only keep those variables that are numeric and non-binary. These variables are age, blood pressure, cholesterol, heart rate, all peak, and my response variable, heart disease. So here I display a summary of the variable values to get a perspective regarding the distribution. Concerning heart, which is a variable that takes the value of 1 if there is a heart disease and 0 if it's normal. Its mean is above 1/2, indicating that there were more people with a heart disease. Here, the histogram reinforces the fact that more people suffer a heart disease, and for a basic exploratory data analysis, let's have a view to the linear correlation of heart disease with the rest of the explanatory variables. Those that are more correlated with a heart disease are heart rate, negatively, and all peak, positively. The model will provide other relevant insights. Running a multiple linear regression model in R, I get the following coefficients for each value. I decided to use a multiple linear regression model since I want to fit one dependent variable subject to other several independent variables. From the coefficients, we can affirm that age, although it holds a possible relationship with a heart disease, is not the most meaningful explanatory value for a heart disease. Now, the intercept is positive since the predicated heart disease mean is positive, meaning that correlated people tend to have heart issues, which we saw from the mean and histogram of the heart. Multiple linear regression model shows that the most important attribute value that favors patients with heart disease is all peak. To help me assess the entire model, I look at the standard errors. According to their values, which are close to 0, we can conclude that the observation fitted well around the regression line. For this model, the corresponding assumptions produce a normal distribution from the residuals with mean around 0. The QQ plot above suggests that the standardized residuals behave as normal theoretical quantiles, in agreement with assumptions which imply that the error components follow a normal distribution as mentioned before, implying a well-fitted model. Once again, the standard errors show that, as above stated, the model does fit well with the observed values. Moreover, the t-values prove that the coefficients are way bigger, both positive and negative wise, than the standard errors, except for the blood pressure variable. The value of the F static means that the variable helped to improve the explanation for the response variable heart disease. Besides, the p-value implies the same, that all the coefficients are relevant to the model. The regression analysis did not fully confirm the hypothesis established in the introductions, since the coefficient for the age variable was very small. Despite the result, one remarkable and interesting finding was that the all peak is the characteristic that most incites to heart disease. From the intercept value, it is established that usually people do have heart disease, even before considering all the characteristics from the model. One limitation was the lack of variables to bear describe implications that cause a heart disease. Compared with this, a large number of observations could have helped to acquire more insightful information. In a nutshell, the project was about the issues that cause a heart disease and to see if, through a regression model, I could assess when it would happen before it happened. First, I limited the variables to the numeric and non-binary ones to run the model and used a basic exploratory data analysis to start the analysis. Afterwards, the regression analysis exhibited a behavior with the dependent variable, heart disease, similar to the one exposed with the linear correlations. Given that the old peak is the most explanatory characteristic for a heart disease, we may consider a simple linear regression model regarding on this variable, where I obtain these coefficients and the fitting measures show an improvement with respect to the multiple linear regression model. And lastly, here is the source where I obtain the dataset. And thank you, that's all my presentation.